So if you talk about the installation procedure on the Matlab, so you can visit our official website, this nanoacademy.com, and then you can go to this document and tutorials. And here you can see this is the nanodical, and this is the installation procedure. So before installing this nanodical software, so please make sure your Matlab has been downloaded in your computers. And for compiling any input file, you need a compiler, C compiler, because this software is written in Matlab and C language. So you need a C compiler so that you can run any simulation. So first you can write this command, max setup. You can copy this one. So before going to this max setup, you can go to this user portal. And here you can create your account and select this product. So first you need to create an account, and then you can go to this product and select this nanodical. So from here you can see this is the download nanodical. First you can download this nanodical zip file, and then you can extract this zip file in the C drive. Here you can see this file already there. This is the nanodical that has been extracted in my C drive. So you can download this zip file, then you can extract in the C drive, and then go to this Matlab application, and here you can write max setup. And then you can enter.
If I have already installed the software, then I have to download it again?
So which software you are already downloaded?
This one, the Device Studio Nanodical.
No, here you can see. This is the Device Studio. That is a graphical user interface.
Okay.
So graphical user interface as well as simulation engine is there. But for this Matlab simulation, you need this file, nanodical 3.1.
Okay.
Here you can see this is the file that you need during the Matlab installation.
Okay.
So once you download it and extracted in the C drive, then you can go to this Matlab application and select this directory. So this is the C drive directory, and this is the nanodical. Here you can see all the folder are there. And here you can write this command, max setup, so that you can configure your compiler.
I hope you are recording this session.
Yes, right? Yes, I am recording.
Okay.
So here you can see this is the MinGW64 for the 64-bit operating system. You can go. Here you can see this GCC for the Linux, and LCC Win32 is for the 32-bit operating system. And if you have 64-bit operating system, then this compiler you should install, MinGW W64. So this is the compiler. And here you can select this max setup C++, because this software is written in Matlab and C. And Nanodical Plus version is written in Python and Fortran. So for the nanodical, you can select this C++, and here you can see max configure to the MinGW64 compiler. So the configuration has been successful. And then here you need to write the nanodical install. So you need to write this command so that you can install the nanodical software in your Matlab. You can press the enter. And this is the license agreement for this nanodical software. You can see this is the license agreement. So you need to accept it. Here you can see I accept the end user license agreement. And then it will start the installation procedure. This is for the parallel simulation. Here you can see. Code classes common, MPI private, MPI proxy is for the parallel simulation. Now you can see Nanodical has been installed successfully. So once this software has been installed, you can go to your user portal, select this product, select this Nanodical, and then you need to install the license file. You can see this is the license file. You can download, you can accept it, confirm. You can see this is the license file. You can see the license has been downloaded, and this license file, you can see this is your Matlab, and this license file you should move on this folder. So you need to create a folder in your home directory, .nano academic, nanodical. Then you need to paste this license file. Here you can see this is my C drive, this is the user, and this is the Nano Academic. So this is the .nano academic file, and this is the nanodical. Here you can see this is our license file. So here you should paste this license file, and you can copy its location, and go to this edit variables. You can see edit the system environmental variable. Select this environmental variables. Here you can see this is the nanodical license path. So if you want to create a new, so you can click on this new. You can paste the license location here. And here you can write license.alic. And in the variable name, here you can see, you can write this nanodical license path. So you can copy this one, and here you can click nanodical license path, and then you can click on this OK. So this is our nanodical license path, and here you can see this is our license file. So you need to set up the environmental variable like that, nanodical license path, and then click on this OK. So once you set up the path, then your complete installation procedure will be successfully. And then you can open your device studio. Either you can open your device studio, or you can write any script. So if you are expert in writing the script, so you need to create a file. So here you can create a file, scf.input file first, and then you can write the script. Like here you can see. So this is our graphical user interface. So any structure you can create, and you can generate their input file. Like you can see, and this is the silicon crystal structure. And you can go to the simulator, select this nanodical, and first you can generate the HCF calculation. So here you can define your own parameters. So as per your need, you can define the parameter, and then you can click on this generate file so that their input file will be generated. Here you can see this is the HCF dot input file. So just you can create a new, just you can create a HCF dot input file and go to this Matlab application. From this browse option, you can locate your project. Here you can see this is our device studio project. And here you can see this is my project file, Matlab integration. Here you can see this is the SI, and this is the nanodical crystal folder, and this is the .NAD file. Like this is the neutral atomic database, silicon LDA double zeta polarized .NAD file, and this is the nanodical crystal folder. In nanodical crystal folder, you can see this is the SCF dot input file. So for running the simulation with the help of Matlab application, you can write nanodical SCF dot input. Here you can see this script you need to write for simulating the SCF input file. You can see this is our SCF dot input file, and this is the nanodical SCF dot input file. So you need to write this script and press the enter. Here you can see the simulation has been started.
Will it take same time as it used to take in software?
Yes, it will take the same time.
Okay.
Here you can see the simulation has been completed, and here you can see this is the log file, this is the calculated result file, and this is the nanodical object.mat file. So the simulation has been completed for the scf.input file. And like if you want to create a band structure, density of state, so again you can click on this device studio and just go to this analysis part. You can create any input file, like this is the density of state, this is the band structure. So here you can see the input file has been generated. This is the input file, band structure dot input file, and this is the density of state dot input file. So you can open this band structure dot input file, and you can enable this command, calculation band structure plot, so that your output will be plotted, and you can remove this command. So you can just enable this command and control yes, so that it will be saved. And again, for running this band structure dot input file, here you can write nanodical band structure dot input file. So this is the nanodical, and this is the band structure dot input, and then you can press the enter. Here you can see the simulation has been completed and their output file has been generated. So this is the band structure output.
If I would like, can you show the result again?
Yes, yes. Here you can see this is the input file, and this is the band structure output folder.
Yeah, can I get the table, I mean the main data from this figure?
Like
and the
you
another
can see,
thing is that what is U, X, G, X, W case. So these are the bands. So can I get the theory of these things?
yes, for their output, you can see this is the figure, a 5G file, and this is the .mat file. So you can open this band structure.mat file, and here you can write the command data. You can see this is the command data, and then press the enter. You can see all these value are there, like this is the band gap value, this is the bottom of the conduction band value, this is the top of the valence band value, and this is the band energy. Here you can see this is the symmetry K point. And if you want to show the theory, like top of the valence band, bottom of the conduction band, band gap, so here you can write again data dot description. So this command you can write and then press the enter. Here you can see this is the band gap, this is the top of the conduction band, bottom of the conduction band, top of the valence band, band energy, Fermi energy, symmetry K point, index, and this is the symmetry K point.
Okay, I got it. Thank you.
Similarly, if you want to run any other input file, like this is the density of state input file, again, you need to enable this command and you can delete this command. So first you can enable this one and you can delete this one. Control yes, so that the input file will be saved. And again, you can write nanodical density of state dot input. You can see this is the nanodical, this is the density of state dot input. Then you need to press the enter, and here you can see the simulation has been completed and their output file has been generated.
One more thing I would like to ask. Is it possible to calculate thermal and electrical conductivity in any of your softwares?
Yes, for thermal conductivity, here you can see this is the ZT option for the thermoelectric properties, so that you will get the thermal conductivity, electrons phononic. So for that, first you can calculate the Hessian. You can see. So this is the Hessian input. Hessian dot input. So once this simulation finished, Hessian dot input file, then you can go to this simulator, select this nanodical, go to this analysis. Then you can select this ZT.
What
This
is
is for the
ZT? What you
thermoelectric
told?
properties.
Thermoelectric property. Okay.
Yes. So once this simulation finished, then you can generate the ZT input file.
I just want to see for one element that how thermal conductivity and electrical conductivity is measured. So for one example, that's enough, I guess.
You can see the Hessian.input file has been completed. Then go to this ZT, and in the primitive cells, you can here you can see this is the nanodical object.mat file, .mat file. So you need to enter this file and then generate the input file. You can see the ZT input file has been generated. And again, you can write this nanodical ZT.input. Once again. So here you can see the thermoelectric property has been calculated. So here you can see the simulation has been completed, and here you can see this is the thermoelectric property.xml file. So you can see this is the conductance, this is the Seebeck coefficient, thermal conductivity with respect to electronics. Here you can see this is the thermal conductivity with respect to temperature. And if you want to show with respect to chemical potential energy, so you can select this one.
I have a question. Suppose there is a flake of graphene or graphene oxide. So how we can say that the thermal conductivity is on in plane or the out of the plane direction? In which direction it is calculating? Because in both direction it will be different.
Sir, your voice is a little bit low. Can you speak loudly?
Yeah, actually, I'm saying that if we have a flake like a graphene oxide or graphene, and I would like to calculate the thermal conductivity in
Okay.
plane and the parallel to the plane. So how can I check that and calculate it? Because for both it will be different for both case.
So
You
for
got the idea?
the like yes,
You got the idea, right?
yes, like for the thermal conductivity for the in plane and out of the plane. So
Yes,
I
yes,
will,
yes.
yes, I will check this point and I will let you know.
Okay, okay. Thanks. Because this is the property which I am doing the research.
Yes. So this is the thermal conductivity for the electronics, and this is the thermal conductivity for the phononic.
Okay. And how it is calculating the thermal conductivity? I mean, it should have two terminal, right? So which terminal it has been taken? I mean, whether it is taken for in plane or out of the plane. That's what I'm asking.
Yes, yes. At this point, I will check. Then I will let you know.
Okay, okay, fine.
And this is the jetty.
Okay. So in the same manner, if I will give the command of theory in Matlab, so will it give the all parameters theory?
Yes, it will calculate it. Like here you can see. This is the jetty input file.
Here we can't see that theory, right, in the software.
Here you can see. You can also run from this Matlab application.
Okay. So can I see theory in
Yes,
the
yes,
graphical
you
user
can.
interface?
Yes, you can visit our official website, document and tutorials, Nanodical. Here you can see this is the theory. Like this is the band structure. So all the theory are there. And for the input parameters, you can select this input reference. So what the input parameter you need to define. And here you can see this is the calculated parameters. Here you can see this is the parameter for calculating the thermoelectric properties. So you can visit this website for the theory purpose. So all the theories
And
are there for
please,
this into
please
difference.
confirm that what I asked for thermal conductivity, the same thing applies to the electrical conductivity. How it is calculating the electrical conductivity in plane or out of the plane?
Yes, this point I will check and then I will let
Yes,
you know.
yes. I'm saying that check for both case for
Yes, yes,
electronic
for
and
the in
thermal.
plane and out plane.
Yeah, no, for electronic and for thermal both.
Okay, sir. Okay.
Okay. Yeah. And one more thing, you said previously that you are going to give us this trial version for 3 months, right?
So you had discussion with me or my colleague Anil Salman.
Maybe Shad Anil Sharma, the salesperson.
Okay.
So you, what's your name? Because your name is not visible here.
Yes, yes, myself Deepak Upadhyay.
Okay, okay, okay. So maybe we had a communication. Okay, I will talk to him directly. Okay, so that's it from my side. I mean, I got the clarity that how to do that. If I will get stuck in something, then I will let you know.
Okay, sir. Okay.
So could you please share this recording?
Yes,
Maybe
I will
in,
say. Yes, I will say.
yes, yes. Okay, thank you so much for your time.
Okay, sir. Thank you so much. Thank you.
Okay.